Hi everyone, my name's Austin and I made a project about posture detection. So my slides are going to be kind of dense, so sorry, I'm going to go through them pretty quickly to stay under the 4-minute limit, which I just learned about recently. So posture has been negatively affected for the last 20 years especially. You got texting neck when you look down at a phone, you got chronic conditions when you bend over to see a computer screen over time, and my idea is to make a data set where you have good posture and bad posture and train that on a neural network architecture that I create and then compare the results to existing one. So here you can see my idea where you have a device that looks at good posture and bad posture. These are actual images from the dataset, by the way, on the right side of the slides. And it tells you if they're good or not. So the data collection, I took about over 2,000 images, tried to make them vary to conditions, so you got different people walking back and forth in those images. And I labeled them using RoboFlow, which is a free annotation web service. My dataset's public too, if anyone would like to use it. You can just pause the slide. So this is me annotating a bad posture actually, and this is me annotating a good posture. And yeah, it took a while, but I think it was worth it. So I exported it as a CSV file, a TensorFlow format, even though I'm using PyTorch, it worked out. And then I tried to use Homework 2 code, but unfortunately, I realized it uses the CIFAR10 dataset, which, from my understanding, classifies the whole images instead of bounding boxes. So I need to use a different model approach, which outputs a label and then 4 values, which are the coordinates of the bounding box, which I found here. It uses a pre-trained model and then has 2 modules, a label classifier and then a bounding box regressor. And then it back propagates, as you can see. Oh, one more animation. Back to those 2 modules so it can learn efficiently. And the base model I used was ResNet V2, which we learned about in class. And then this is the first architecture. I actually used batch size 1024 by accident, which isn't good because I only had 2,000 images. But then I used 32, which you can see on the lower right corner. And then you can pause the slides if you'd like to see the specific architecture. But I used 2 different architectures. One had more linear layers than the other, and this one performed better actually. Although they both didn't perform as good as I hoped. So I actually wanted to use MobileNet V2 as the base model, but I didn't get it working in time, so sorry about that, guys. But this would have been good because it runs really fast on stuff like Raspberry Pi, Jetson Nano. So I did use this existing architecture, which is RoboFlow's machine learning object detection algorithm, and this is how it did. It did actually very, very well, I thought, at least better than my architectures. And here is an example of that.
Poor posture detected. Remember to maintain good posture. Please adjust your posture. Please adjust your posture.
Alright, so here's an image. As you can see, it does pretty well. It wasn't 100%, but it found the poor posture, so I was pretty encouraged by that. So, we already watched that. So looking forward, I would like to be able to do a few things, among other things. I want to pose estimation, as you can see on the right, is a cool field of research right now. And that could have been a good way for me to head in the future. Also, I'd like to improve problems I have in my neural network model, ask more people to participate in the dataset collection, and apply transformations to the dataset I have. Like, probably not rotational transformations, but stuff like grayscale, blur, horizontal flip. And yeah, thank you for watching. Hope you guys have a great day.